To solve equations involving fractions, we need to know how to add and subtract algebraic fractions. For example, if we want to simplify the expression x over 3 plus x over 5, we need to consider how we can get a common denominator. We know that the lowest common multiple of 3 and 5 is 15, so that's going to be our common denominator. We've basically times 3 by 5 because the lowest common multiple of 3 and 5 is actually 3 times 5. X over 3, in order to make the 3 into 15, we've multiplied the bottom by 5, so we also need to times the top by 5 in order to keep the fraction balanced, because the 5s would cancel out. So we have 5x over 15, and then we've multiplied 5 by 3 in order to arrive at 15, so we need to times the top of the second fraction by 3. So we have 5x over 15 plus 3x over 15. These are just equivalent fractions to the fractions on the left-hand side of the equation, so we're allowed to put this equal sign in. We can now add the numerators, so we have 5x plus 3x over 15. We don't add the denominators, and that gives us 8x over 15 as our final expression. However, when one or more of the denominators has a variable, we actually need to multiply the denominators in order to make a common denominator. So, for example, if we have x over x minus 1 plus x over x plus 2, to arrive at a common denominator, and generally you'll write it as one fraction straight away. To get a common denominator, we need to actually multiply x minus 1 and x plus 2. So we'll have x minus 1 times x plus 2 as our common denominator. Now, x over x plus 1, we've multiplied this fraction, we've multiplied the denominator by x plus 2 in order to reach the denominator x minus 1 x plus 2. So we need to multiply the numerator by x plus 2 also. So that means we have x times x plus 2. If you imagined just having this expression here, the x plus 2's would cancel, and that would leave you with x over x minus 1. That's a good way of checking to see if you're right. Then we have x over x plus 2, but in order to make the denominator here, x minus 1 times x plus 2, you've got to multiply it by x minus 1. So we need to multiply denominator and numerator by x minus 1. So we will have plus x times x minus 1. We can now neaten up the top a little bit. So what we could do is take out a factor of x on the top, and then we have x minus 2 plus x minus 1. And finally, we could simplify in this second bracket in this large bracket here. So we have x bracket, x plus x is 2x, minus 2 minus 1 is minus 3, all over x plus 1, x plus 2. Occasionally you'll have something like this where there is an easy to spot common factor. So if I wanted to simplify fully here, I should notice that I don't need to multiply x plus 1 and x plus 1 squared, because there's a common factor of x plus 1, because if you remember, x plus 1 squared is really just x plus 1 times x plus 1. So here, the lowest common multiple of x plus 1 and x plus 1 squared is just x plus 1 squared. Now x plus 1, to reach x plus 1 squared, you've had to multiply by x plus 1. So we need to multiply top and bottom by x plus 1 for the 5x. So we have 5x times x plus 1, and then we have a minus, not a plus. Now 3x doesn't need to be multiplied by anything because it already has a denominator of x plus 1 squared. So we just have take away 3x. And we can now simplify the top. So we could take out a factor of x again. So we would have x bracket 5x plus 1 take away 3 all over x plus 1 squared. We could expand the bracket inside, so we have 5x plus 5 take away 3, which will give us 5x plus 2, and all of that's over x plus 1 squared. Here are some practice questions for you to try. I'd like you to simplify these fractions by writing them over a common denominator. Please pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers. To solve equations involving fractions, the general principle is to deal with the denominator and then solve. So in example A, we have x over 2 plus x over 3 equals 10. To deal with the denominators, I'm going to get a common denominator. Lowest common multiple of 2 and 3 is 6. So that's going to be my common denominator. So I've times 2 by 3 to get 6. So I've got 3x. I've times 3 by 2 to get 6. So I have 2x. That equals 10. So I can say I've got 5x over 6 is equal to 10. I can multiply both sides by 6, which will give me 5x equals 60. And then I can divide both sides by 5, which will leave me with x equals 12 as my answer. In question B, we need to get a common denominator again. Lowest common multiple of 5 and 10 is 10. So my common denominator is going to be 10. I've times 5 by 2 to get 10, so I'm going to do 2 times x minus 3. So remember, it's times by all of x minus 3, plus x plus 2, because I don't need to times that second fraction by anything on the top and the bottom, because it already has a denominator of 10. That equals 9. Let's neaten up the top a little bit. So I've got 2x minus 6 plus x plus 2. I've just expanded the first bracket, or the only bracket, over 10 equals 9. We have 2x plus x is 3x, minus 6 plus 2 is minus 4, over 10, and that equals 9. I'm going to multiply both sides by 10, so I get 3x minus 4 equals 90. I'm going to add 4 to both sides, so I get 3x equals 94. And finally, we can divide both sides by 3. So we get x equals 94 thirds. We can simplify that. 94 thirds, 3 into 94 is going to go 31 times. 31 times. It'll go 31 times with a remainder of 1. So we have 1/3. That makes sense. Then we have 31 and a third. So x is going to be 31 and a third. Finally, you might have, here's a slightly harder example. In order to deal with the denominators here, because they're on different sides of the equal sign, we can cross multiply. What I'm going to do first is multiply both sides by x plus 2. Let's write this out first. So firstly, I'm going to multiply both sides of my equation by x plus 2, because that will deal with the denominator on the left-hand side. Remember, this is the same as multiplying by x plus 2 over 1. So we could just write this as x plus 2 over 1 on both sides. On the left-hand side, the x plus 2 factors will cancel. So on the left-hand side, I just have 1. On the right-hand side, I have 3 times x plus 2 over x minus 4 times 1, which is just x minus 4. I then multiply both sides by x minus 4. again, x minus 4 over 1 if you like. This will make the x minus 4 on the denominator at the right-hand side cancel. A lot of the time we will just do this in one go, so you'll just multiply by x plus 2 and x minus 4 in one go. That's why it's called cross multiplying, because it's sort of like a cross. You're moving one to the right side, one to the left side if you like. So we have x minus 4 equals 3 bracket x plus 2. We can expand this bracket to give us x minus 4 equals 3x plus 6. We can then subtract x from both sides, so I have minus 4 equal to 2x plus 6. You could subtract 6 from both sides, so we have 2x equals minus 10, and then divide both sides by 2 to give us x equals minus 5 as our answer. The hardest kind of equation involving algebraic fractions is going to be one which involves you forming a quadratic equation. So here I'm going to start exactly as before and get a common denominator. So I have x plus 2, x minus 3. The first fraction I have multiplied the bottom by x minus 3. So I have x minus 3 times 1, which is just x minus 3. The second fraction, you've multiplied top and bottom by x plus 2. So I need to have 3 times x plus 2. And all of that equals 5. I can expand on the top. So I have x minus 3 plus 3x plus 6 over x plus 2 x minus 3, and that equals 5. Just to neaten up the top. So on the top we have 4x plus 3. All of that is over x plus 2 times x minus 3, and that all equals 5. We can now multiply both sides by x plus 2 x minus 3. So we end up with 4x plus 3 equals, because we've multiplied both sides by the denominator to cancel it out, equals 5x plus 2 x minus 3. So on the left hand side we have 4x plus 3. And on the right hand side we have 5 lots of this pair of brackets. So what I'm going to do is put in a square bracket after the 5, and inside those square brackets expand x plus 2 x minus 3 using FOIL. So I have first x times x is x squared, outside x times minus 3 is minus 3x, inside plus 2x, and last 2 times minus 3 is minus 6. So I have 4x plus 3 equals 5, and then in the square brackets x squared minus 3x plus 2x is minus x minus 6. So I have 4x plus 3 equals, and now I can expand this square bracket. 5 times x squared is 5x squared. 5 times minus x minus 5x. 5 times minus 6 minus 30. And then I can see I have a quadratic equation. I'm going to take everything over to the right hand side, so my equation equals 0. So I'm going to subtract 4x from both sides and 3 from both sides. This will leave me with a final expression of 5x squared, take away 9x, take away 33 equals 0. Now this is a quadratic which I cannot factorize, so I'm going to use the quadratic formula. So just to remind you, every quadratic has the form ax squared plus bx plus c equals 0. And the solutions are given by x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So here a is 5, b is minus 9, be careful, and c is minus 33. So substituting these values in, I have x equals minus 9 plus or minus the square root, and really we ought to work out b squared first. So minus 9 all squared. Take away 4 times 5 times minus 33 all over 2 times 5, giving me x equals 9, because minus minus 9 is 9, plus or minus. I'm going to put this into my calculator. So minus 9 squared is 81. And then I have minus 4 times 5 times minus 33. I get 741. So x equals 9 plus or minus root 741 over 10. So one of the solutions comes from putting a plus in the formula and one from a minus. So I have x equals 9 plus root 741. I'll put it in brackets actually. 9 plus root 741 all over 10, giving me an answer of 3.62 to 2 decimal places, or 9 minus root 741 all divided by 10, which gives me minus 1.82, and those are my solutions. So just to look at it in full, we got a common denominator of x plus 2x minus 3. We multiplied both sides by that common denominator, so we essentially didn't have any denominators then, we dealt with them. We expanded and simplified, got everything over to one side of the equation so it equals 0. Identified a, b, and c, substituted into the quadratic formula, and solved. Here are some practice questions for you to try. Please pause the video now and have a go at them, and when you're ready for the answers, press play. Here are the answers.